Okay. Good afternoon, everyone. My name is Eyad Kannout from University of Warsaw. I'm glad to present a paper utilizing frequent pattern mining for solving cold start problem in the recommender system. This paper was done in collaboration with my colleagues Michał Grodzki and Dr. Marek Grzegorowski. So as we can see in the agenda of this presentation, first we will talk about the goal and motivation of this paper. Then we will give overview of for recommender systems, short one, also for the cold start problem. Then we will talk about the PeRS', the framework that we have introduced to address the cold start problem. Then we will talk in more details about the strategies we used to address this issue. And finally, we will show the evaluation methodology we followed and the results. The goal of this paper is to introduce a hybrid recommender system. This recommender system incorporates collaborative and content-based filtering algorithm in order to address the cold start problem. Our main contribution to produce this framework utilizes frequent pattern mining. We utilize the item characteristics and users demographics in order to generate or extract sort of, let's say, important pattern that we can use to make a new prediction for the new users and the new items which are added to the system. We use the two data sets. We will talk more about it in details in the evaluation methodology part. So before talking about the recommender system, the most important techniques in the recommender system, I would like to say this area has received more attention recently, especially after COVID pandemic. The majority of e-commerce companies switched to the online services, and that's not enough for them. Each company would like to incorporate a recommender system that can improve the experience of the users while using their platforms, in order, of course, at the end to increase their profits. So regarding recommender systems, there are three main types. The first one, collaborative filtering. In the collaborative filtering, here we don't use item characteristics or user demographics. The only thing we rely on is the rating. The rating here can be given explicitly or implicitly. So you don't always need to say, I rate this product 3 out of 5 or 5. It can be done without your attention, like even if you just view the product or just click on it or keep the screen open on it, everything can be recorded in some website, and then we can catch your feedback. So in the collaborative filtering, only ratings are considered. There are two types, memory-based techniques and model-based techniques. In the memory-based techniques, we rely on k-nearest neighbor. In the model-based techniques, we build predictive models that can learn some models based on the rating history. The most popular is matrix factorization, like singular value decomposition. In the second one, content-based filtering, here we start using the item characteristics or user demographics, support vector machine, frequent pattern mining, like what we used here, can be used. The hybrid, when we combine both of them. This is the basic element in the recommender system. Simple matrix. The rows are users, columns are items. Our target is to predict those zeros. I don't want to spend a lot of time here to talk more about the strategies that we follow to handle the cold start. Those algorithms usually suffer from many limitations and challenges. So some of them, scalability. This matrix that we show, usually the size of it increased significantly. It impacts in many algorithms the latency. So that's one issue. Sparsity. Some of them are, the majority of the values are zeros. Scalability, explainability also. What we focus here is the item cold start problem and the user cold start problem. When the new user sign in the system, this user doesn't have any rating history, no interaction with the system. How can we predict something for this user? The same for the items. Some companies like produce new items, and then they complain no one buying our items. So we would like to increase our profit, and we would like to sell it more. So this is the item cold start problem. So the FBRS that we introduced is supposed to address both of these issues. Why we use frequent pattern mining? In general, frequent pattern mining can be used to discover the important relationship and associations between items. The main difference between this and collaborative filtering, here we discover the global and shared differences across all users. While in collaborative filtering, we take each user in dedicated case and find the nearest neighbor and then make a new prediction. While the information that we received here can be used for all users. This is the difference. Global preferences. This is the key points here. It relies on the support measure. I think it's a very popular measure. It gives an idea how frequent item set in all data sets. This is the formula of this measure. Why we use frequent pattern mining? Because the most popular one is a priori. A priori is very slow, and it is crucial point in recommender system to generate those frequent patterns very quickly. So there is a frequent pattern tree structure can store the data in concise and compact way, and then this data structure can be recursively divided using divide and conquer algorithm to extract and mine those frequent patterns without keep scanning the database over and over again like in a priori. That's the idea why we use FP growth. This is FPRS, the framework that we introduce. In this framework, firstly, it's composed of, let's say, 4 stages. In the first stage, we take the data set. We combine the user demographics and item characteristics and ratings in one data frame. Then we keep the favorable ratings, only the ratings that are favorable, which means in terms of rating from 1 to 5, we keep more than 3. In terms of rating out of 10, we need to decide about this based on doing some experiments. After that, we do some attribute analysis. We try to check the item characteristics, the user demographics, to see which one can be used to split this data and keep having representative amount of records. Because we need to split this data based on those item characteristics and user demographics. Then we split the data. We have smaller data sets. We take each one of them. We apply frequent pattern mining. Then we involve multiple strategies to use those frequent pattern mining to address cold start problem and for users and items. What are those strategies? For user, the first strategy, we use entire data set. Here we don't do any split. This is the simplest way. We generate frequent one item set. We don't generate more than one. Then we got an idea that those items are very popular because they are rated highly alone by significant amount of users. So we got the sense that those are very important and very popular and rated positively. Then we recommend them to any new user. This is the simplest one. The second one, we start here splitting the data sets using the user demographics. For example, let's say gender. We take here. We generate again the item set, frequent item set that of course satisfy the minimum support threshold that we identify. Then we recommend to the new users all those item sets based on their gender. Okay, so here we know that those are popular for male. If the new user is male, we push those recommendations for the user. For the item cold start problem, we use more, let's say, advanced strategies. Here we split based on the item characteristics. Then again, we find the frequent item set, and we introduce here so-called participation threshold. What does it mean? We take those frequent item sets and then how many users, okay, the users that involved in creating those frequent item sets more than this threshold means that those users are interested in this genre. Taking an example here, we're talking about the genre. So it's not enough if I just involved in creating 1 or 2 item sets that I am interested in. For example, action movies. So after having this data, when we have a new movie that belongs to this genre, for example, I push this movie to that user. This is the first strategy. Here, we do more granular split. We split by user features and item features. We start including the genre as well. So now we have for each item feature two, let's say, bars, one for me, one another for me, and then we find the dominant one. Dominance means how many frequent items it has. The one which has more, it means that this part of users prefer this genre more than the other. And then finally, we recommend the new item based on this popular or dominant user feature. The last one, here we start including some clustering techniques. After splitting the data here based on the user and item features, we generate frequent one item set, only for the size one, and then we put each one of those groups in a cluster. We assume that this is a cluster, and then when we have, then we find the center of each of those clusters. When we have a new item, we calculate the distance between each one of those clusters, and the closest one means that this new item can be recommended to all users that have been involved in creating these frequent patterns. So this is the idea of the last strategy we introduced, the item could start problem. Regarding the evaluation, we use two data sets, Mobilance 100K and Mobilance 1 million. The first one has 900 users, 1,000, almost 700 movies. The second 1 million rating, 3,900 users, 6,000 users, 3,900 movies, 6,000 users. We did some, as I mentioned in the graph for the PeRS', some analysis for the attributes. For example, we took into account the genre for in our experiment. You can take any other item characteristic or user demographics in your experiment. Training, we need to simulate the case. So we take, for example, when we evaluate the user cold start problem, we take arbitrary select 20 users. We take all their ratings from the data set, so they are unknown. The same for the cold start problem. In terms of the user cold start problem, the testing set had around 9,000 records. In terms of item cold start problem, around 40,000 records for the 1 million. 40,000 records for 1 million and 7,000 for 100K. We introduced a baseline. It's not easy to evaluate this. How we evaluate this against the baseline for the user baseline model? We go through each movie, and then we find the most common gender and age group. This is how the baseline will make a recommendation for the new user. So we have a new user. We know that each movie, what is the dominant age group for this movie? So if the user belongs to this age group, we will push this movie or this item to the user. For the item, we do it in analogous way. But for each user, we find the most popular gender. So once we have a new item, we know that each one of our users, which gender he or she prefers, then we push the item to the user. Evaluation metrics, I will not go into details here. Just want to say that this is binary. Let's call it model, recommend or not recommend, because it is when we address cold start problem, as I mentioned, there is no rating given. So we just need to know, should we recommend this or not? We use precision, recall, F1 measure, and accuracy. Let's take a look at the results. So for the user cold start problem, we see that the FPRS outperformed the baseline, except for the recall. Why? The reason is the baseline is quite selective. And if we go back to the previous slide, we go back to the previous slide. In the recall, we don't care about false positive. This is very important recommender system because the false positive mean we recommend something and there is a high chance we will push it to the user. In the recall, they don't care about the false positive. So baseline was making a lot of mistakes, but because recall doesn't care about this, it achieved very high rate in terms of the recall. So we need to select the proper. This is example, like we need to focus on the proper measure when we evaluate our model. So that's what we spotted while evaluating this. So that's why the recall was here very good for the baseline, but in reality, it was not doing very well. For the item called start problem, PeRS outperformed the baseline. However, we need also to select the strategy carefully. Why? It actually at the end it depends on the business itself. For the 100K, for example, we see that strategy 3 and 4, strategy 4 is better in terms of precision and F1 score, but strategy 5 is better in terms of accuracy. Accuracy, also, if we go back to the previous slide, it assumes that all those measures are equally important. So finally, really, we need to understand here what we need from the business here. If all those measures are important, go to the strategy 5. If we focus only about what we push to the users, let's focus about precision. So here also, that means I cannot now tell you strategy 3 is better than 4 or 4 better than 5. We need always to think about this and consider the business requirements. The last part of my presentation about doing some experiments. So we show that how changing the thresholds, the minimum support and the participation threshold can impact the result. So the performance of PeRS. So we do some, we repeated some the evaluation for different values. So for example, for the minimum support, we found that something around 20 is sort of optimal value. That's why we select this in our experiment. For the participation threshold, something between 0.25% to 30%. Participation threshold is somehow the one that gives us the best result. Future work. What I wanted to say before the future work, that finding this frequent item set don't only help us to address these problems. It helped us also to speed up the recommendation by doing some filtering. I'm just giving you some ideas. Filtering, we don't need for each user when we want to make a recommendation for the user to evaluate or predict the rating for all movies that he didn't use in the past. This will take some time. And if we care about the latency, this could help us to filter them. And this is the idea of our other paper, which was accepted recently in ACI IDS conference. So that was one of the future work, which I didn't mention here. So we need, regarding this, we plan to extend the strategies, especially for the user. Maybe you spotted it is still not very advanced like in the item. We plan to introduce some so-called not items, frequent item set, but frequent user sets as well. This actually showed us that it also gives better result than the strategies we use. Incorporate contextual information, not only the user and the item features. Also, we can use PCA to create new features and also use them to make this split. This is also another idea that we are working on. Evaluate another algorithm, not only FP growth. Evaluate this also against another baseline. I think, yeah, and considering change in the user behavior. So we need to make sure like these frequent patterns needs to be updated from time to time because the preference of the users and item are changing. But of course, we don't need to do that every 1 hour. That's all in my presentation. Hopefully it was clear. Thank you for the very nice presentation.
data set that you use for your experiments is movie lens. And don't you think that your results can be extended to other areas in terms of recommendation algorithms? For example, if we were interested in improving friend recommendations on Facebook, don't you think the ideas that you are proposing can be applied?
Definitely. What we are doing now, part of the future work, is to evaluate these strategies against totally different domain, not only movies. We are trying now to check in terms of there is a data set related to the SoundCloud, to check the features of the recording or of the song, whatever. Regarding friend suggestion, it can also be used. It can be generalized actually. Only thing you need to consider item characteristics and user demographics. When you use them, you have enough amount of data. So you cannot, for example, use a feature and then split your data set where the first part has 90% of the record and the second part has 10%. This is the only, let's say, thing that you need to consider while applying this, but it can be generalized to any domain.
Thank you. In the slide where you showed the results of your evaluation,
Yes.
that was, I'm not sure. Sorry, I didn't see correctly. I was going to ask you why the precision was so low in strategy 5, table 5. But it's not that, sorry, it's not that I didn't see that correctly. So
That's fine.
sure. The other question is, I think precision, you mean the average precision.
This one, yeah.
But I think the result is the average, right? All
Correct, yes. Yes.
the average. And so how many recommendations per user?
For that, you mean the size of the
It's an
testing
average,
data?
right? So how many average per user see that?
The testing set, we selected 20 users.
Yeah.
And here we selected 20 movies. The number of the records here in the 100K, in the testing set, 9,000, in 1 million is 25,000. And here are the number of the records. Here we selected 20 movies.
Right. So so then it's average of 20 recommendations?
Yes.
Okay. Other questions?
This is a repetitive question, probably over the session, but I will. So I have like doubts about comparison of strategies. Let's say you find using any arbitrary whatever methodology to find your best strategy, and you take 2 e-shops, let's say, and install the same strategy which pushes products. Whereas one e-shop is selling, let's say, a brand. It's not. So the only available output compares the impact of some e-shops is the profit of the e-shops.
Correct.
Okay, so no profit shop maybe much higher than shop which. Or if you have several strategies, how do you compare them? Because the only is really
Well, what is used in the e-commerce, usually they give this service based on demand. So I have a deal with you, I have product, you are the owner. Usually you don't, usually if I make some subscription with you, you start using more advanced strategies. And then it's not only the profits that can judge if this product, it can be something else. It can be even if the users start looking at this product more. At the beginning, because the profit can come later. But at the beginning, if more users start looking at this product, telling each other about it, the profit can come after some time. So it's not only this product is sold or not.
Okay, but what you are feeding actually
Yeah.
models is the sexual interpretation of the moment.
Yes.
Because this is probably what measures the performance. Of course, it is very vague.
Mm-hmm.
Actually, is not. This is actually what we want to achieve. All right, this is.
It's much better to look at a different use case, something like Netflix, but then we can actually look at, did the person select what we recommended, yes or no? Sure. They will have statistics on that.
Sometimes they, I mean, the e-stores give some advantage for the users that give their feedback. And in one of the research projects that I have been involved in, they make this. Please provide your feedback for the latest, for the last 20 users and get this voucher. So,
But like online ads and stuff, you know what the click-through rate is going to be.
yes.
Little bit of feedback. Really nice presentation. You're very brave to talk about gender. This presentation in America made me think about this. I have a question. I'm very interested. I really like it, but you talk about performance with regards to accuracy. For these scenarios, I think also the speed with which you conduct these your recommendations when you get your results is also quite important here. So you talked about a cluster and breaking it down into small pieces which compute. I'm assuming something like TensorFlow, or how did you do that? How quickly can you produce results, your results? It's another way to compare, it's another method.
Clustering. So regarding the last.
So, okay, you mean the clustering as in clustering.
Yes, distance metrics.
Okay.
This distance metrics like person correlation.
Yeah, I've got that. Sorry, I thought you meant the multiple machines.
Yeah.
Did you look at anything with distributing your computations to speed them up, or
Not yet. Not yet. Definite was I heard this actually advice previously.
It's very cool that you've got your results, but I think the second question is, if you're sitting with Netflix,
Definitely.
you go, how quickly can you get those results?
Definitely. Totally agree.
I think this guy can sell you that phrase.
So that's why I put in my email to send me your idea.
Question for me. You mentioned that the algorithm that you use in Grow,
Yes.
you have chosen this because it is time efficient during the inference stage. Yeah. So my question is, if you use other algorithm, a priori or one, do you expect that the results can be better in terms of accuracy of once?
The results are the same.
Yeah.
The difference is only in the performance. This is an improved, FB growth is an improved version of a priori
Okay.
that can, yeah.
Okay, so
Thank you so much.
now we can